Hello, everyone, and welcome to our discussion concerning programming Arduino microcontroller. In this video, we are going to look at the application of digital input-output functions to the programming of Arduino microcontroller. The digital input-output functions serve two main purposes in Arduino microcontroller environment. The first function that we can put the digital input-output functions to is to help us read the state of an input pin. And basically for the input pins, we can do that for the analog input pins in case or in situations where we want to use the analog input pins for the digital input output. But of course, the digital pins operate both as input and output pins, depending on how they've been configured. And therefore, we can use the digital input-output functions to read the state of an input pin, that is whether digital or analog. Two, we also use the digital input-output functions to generate a logical high or low output for the case of output pin. So there are three main functions that we use under this category of digital input-output functions. The first one is the pin mode function. The second one is the digital write function, and the third one is the digital read function. So I want us to go through these functions briefly, and then we will take a look at an example. So the first function that I want us to go through is the pin mode function. So the pin mode function, as you can see here, for the pin mode function, this is the syntax for using the pin mode function. And basically, before we use an Arduino microcontroller pin, we have to inform the controller how we want to use the pin, because the microcontroller needs to know whether the pin or the port should be used as an input pin or output pin for those which are supported by directional communication or data transfer. And therefore, the pin mode library function is called into action to inform the microcontroller on how it is supposed to use a particular pin. For the digital pins, they operate as input pins by default, and therefore maybe it is just important we specify that we specify the output mode in case we want to deploy them as output pins. But if we want to use the digital pins as input pins, it is not necessary to specify the pin mode, though even if you specify the pin mode, it causes no harm. So for the Arduino Uno microcontroller, which is known to have, for the digital pins in Arduino Uno microcontroller, they are numbered from 0 to 13. They are numbered from 0 to 13. So within the syntax of using the pin mode function, this pin here, you can use a number like 0 to 13 in the case of Arduino Uno, or you can use a 0 to A5 in case you want to deploy analog input pins as digital, or in case we want to deploy analog input pins for digital I/O. Remember A0 to A5 for Arduino Uno microcontroller. Or we can also work with a variable. We can also work with a variable, and I think I'm going to demonstrate that one shortly. Okay, so you find that the pin mode function, take note of that. Here we will put a number or a variable representing the pin that we want to set its mode. And then this mode here can be any of the three. It can be input in case we want to use the pin as input pin. It can be output, or in some situations, we can also use it as input, a pull up, okay? But in many cases, we will be using it either as input or output, okay? Take note of the fact that with the digital input output pins, the input can be considered to be high or low, and the output will also be considered high or low, okay? So in this case now, we realize that when we perform a library function call to the Arduino library using the pin mode function, we specifically telling the controller how to treat a particular port or pin. And that is very, very important in as far as the use of Arduino microcontroller and any microcontroller for that matter is concerned. It is very, very important. So I want to introduce a few examples here. Let me share my whiteboard. So for example, suppose I have the following definition. I have LED connected to digital pin number 13. LED is known to be a digital output device, and therefore it will require that we set that pin to be output pin. So we'll use the pin mode function to set the LED pin as output pin. Or you can still say pin mode into brackets 13, output. But it's not advisable to use the numbers because if you're dealing with a huge program, it is difficult to relate those numbers with the variables they represent. And that is the reason as to why it is important once you have declared the variables, then they are the same ones you use not only in setting pin modes, but also in working with other functions where the entity or the device attached to the pin needs to be mentioned in the function. It is easier. Like in this case, we can easily tell that to digital output pin number or to digital pin number 13, that is where the LED is connected to. Suppose I have another device like a potentiometer. Okay, suppose I have a device like a potentiometer. A potentiometer is known to be an analog input device. So if the potentiometer is connected to analog pin number 0, so I can say integer variable potentiometer there attached to pin number 0. Then now in this case, I will now specify pin mode for the potentiometer to be, input. So in that case, potentiometer is connected to analog pin number A0, and we want to use it as input pin. If I pick like a digital input device, like the push button, then in that case, I can declare an integer variable, call it the push button, and then maybe assign it to digital pin number 3. And then now in this case, I can set pin mode. So I say pin mode into brackets. This push button, we want to use the push button in the input mode. So that one will work for us. Okay, good. So let's have a look at the next function. The next function is the digital write function. So once we have specified a digital I/O pin as an output pin, then now we can write values to that pin that is either a high or a low by using the digital write function. So the digital write function is used in situations or scenarios where we have configured a digital input output pin to be used in the output mode. And therefore now we want to set the pin high or low, basically turning on or off the pin. When we give it a high signal, the pin is said to be turned on. When it is issued with a low signal, we say it is turned off. So that is where we use the digital write function. So this is the syntax for using the digital write function. The pin here is a variable representing the pin number that you want to write to. Like in the previous example, we had the LED connected to digital pin number 13. So in case we want to write to that digital pin number 13 where the LED is connected to, then I will just say digital write the LED pin. That is of course pin number 13. Then we specify the value we want to write there. For example, if I want to turn it on, I will put high there. Okay. And if I want to turn it off, then I'll basically say digital write to LED, and this one is connected to pin number 13, low. So that will switch off the LED. So basically that is how we use the digital write function. The third function that is important in as far as the digital input output functions are concerned is the digital read function. When a digital pin has been configured to operate in the input mode or to be utilized as an input pin, then we can use the digital read function to read the state of that input pin. We can use the digital read function to read the state of that input pin. Again, as is usually the norm with digital functions or digital parameters, the value that will be returned by this function or when this instruction is executed will either be a high or a low. And the syntax is presented here for the digital read function. So pin there will represent the pin whose value we want to read or whose state we want to read. And what it returns will be a high or a low. What it turns will be a high or a low. So for example, if the push button is connected to digital pin number 3, and we want to check on the value that is coming from that pin, then we can say now digital read, then push button. In the previous case, we had connected the push button to a digital pin number 3. Okay, good. So those are the 3 main digital input output functions which are important in programming Arduino microcontroller. I therefore want us to have a look at an example. And in this example, we basically going to read a push button value. The push button is connected to a digital input pin. We'll connect it to digital input pin number 7. And then we use the value we have read from the digital input pin to which the push button is connected to turn on or off LED, depending on the value that is coming from the push button. In this case, we consider the LED as a digital output device, and hence we will connect it to a digital output pin number 13. Just to illustrate, of course, in this case, we're using the Arduino microcontroller, the Arduino Uno microcontroller for that matter. So this circuit here, I have drawn it using Tinkercad. This circuit here, I've drawn it using Tinkercad. So I have put LED there, that is the output device. Then I've put a push button there, which is basically the input device. Then this is the Arduino microcontroller, and I have the breadboard there. And then of course we have the connecting wires. So before we draw the circuit in Tinkercad, I will first of all do the program, and then we debug the program. And then of course, after we've confirmed that the program is free from errors, then now we can draw the circuit and then test our code. So I'm starting Arduino IDE. So I'm starting my Arduino IDE. So let me start a new sketch. So in this case, there are some pin declarations which we need. So let me declare an integer variable, then call it LED, initialize it to pin number 13. So in this case, we're going to connect LED to pin 13. Then we can connect LED. We are going to use it as an output device. We're going to use it as output device. So I can again declare another variable, the push button. Let me call it just pin, where the push button, or I can maybe use a push button. So the push button, now we can connect it to digital pin number 7. Let's connect it to digital pin number 7. So we're connecting the push button to digital pin number 7. And then we can declare another variable to help us hold the value we read from the push button. So again, that will be integer variable. Let me call it value. Then initialize it to 0. So variable called value to store for us the red value. Then under the void setup, here, what we put here will run only once. So we can set the pin modes here. So I can put pin mode. The first pin there is LED. So LEDs are for output device. So let's use it in output mode. So in this case now we will be using, so we are setting pin number 13 as output. Then the push button is a digital input device. So the pin mode there for the push button should be, we can set it at as input. So the push button should be used in the input mode. Remember, this one is in capital. So set pin number 7 as input. That's where the push button is connected to. And then for the void loop part, what we put there is what should be run repeatedly. So there we can put, in this case, we will have, let's assign the value, the variable we declared up there. Let's assign it to the value we get from the push button. So the value we get from the push button, we need to capture it using the digital read function. So I will use the digital read function here. This should be capital R. So digital read, the push button value, the push button value. So the value we read from the push button, we are assigning it to a variable which we had called value. It can be anything, provided you maintain the same name you declare up there. So in this case now, we will be we'll be setting value to be equal to the pin 7 input where the push button is connected to. Then we need to use that value to operate the LED or activate the LED. So in this case, LED is a digital output device. I will use digital write function to LED the same way we had declared it up there. Then now the value that has been read from the push button. So here basically we're setting LED to the push button value. The push button value. So that is our code, which we can debug and test that it is free from errors. So let me save it first. Let me confirm that the right board is selected. Let me select Arduino Uno. Then compile. So there we have the code. It is free from errors. Now I can go to Tinkercad. So let me go to Tinkercad. So I'm starting Tinkercad. Tinkercad requires you create account and register. So we will start from scratch. So I will come and search for the components here. So I begin by searching Arduino Uno. It is here, click, place it on the design area. Then come here, search breadboard, the small one. And just use the small breadboard. Click on it, put it there. Then I can power the breadboard. So I come here, tap VCC, come with it, connect here, give it a red color. Then come here with the black wire, tap ground, bring it here. So we've powered this area, we've powered the lower half of the breadboard. In case you want to power the upper half, you can always look from here. You can always look from there. And then we loop the VCC, which is 5 volts DC. Then the other components we need is LED. So we search LED, pick it, we can come put it there. The other component we need is a push button. Click a push button, come put it there. Then we need a resistor. And click that, come put it here. The LED has got two legs, cathode and anode. The resistor should be connected through anode to VCC there. And then we said in our program that the LED is connected to digital output pin number 13. So take note of where I'm making the connections. This is a control signal. Let me color it yellow. Here, come with it this way, come with it this way, and then wire it to digital pin number 13. Then for the push button, it has got 4 pins. It has got 4 pins. This terminal 1B, terminal 2B, terminal 1A, and terminal 2A. Okay, take note of that. So I can pick another pull-up resistor, come and connect it to the ground, use it to connect that leg of the push button to ground. Then I can connect this side to VCC. Then I can connect the push button is connected to digital pin number 7. So I can come and pick this terminal and then connect it to digital pin number 7 here. Connect it to digital pin number 7. So basically I've done the wiring. This resistor here, I've left the value at 1 kilo ohm. And this resistor here, I've also left the value at 1 kilo ohm. And you can always give them the names you wish. Like now this one is resistor 2. And always give them the name if you wish. So if you click there, if you click the component, you will see the name you've given. But you can also use the annotation tool here, this one here. Like if you wanted to name this one the push button, and you can now come and write here, push button, and you hit enter. If you wanted this one to be LED, so that will be LED. And then this one is the Arduino Uno microcontroller. The Arduino Uno microcontroller. Then you can always drag and then place it maybe where you wish. And then we have the breadboard. That's the breadboard. And then these are resistors. And then of course the connecting wires are there. So that is the circuit. Then now after we've drawn the circuit, then I can go to the Arduino IDE where we had compiled our code. As you can see, the code is free from errors. So I can come copy it from there. Then take it to Tinkercad, and click there. Then go for the text only, continue. And I come here, so it's a C++ or Arduino code. Put the code we had written here. Then start the simulation. So the push button is usually operated by pressing it in. There's one more connection I've not made, so let me make the connection first. The cathode of the LED is not yet connected to ground, so let me connect it to ground. I can even connect it down here so that the LED is fully powered. And I can start the simulation. So we can see the LED is on that point, so I can operate the push button. Just a moment, let me check on the powering of the LED. This is anode. We've connected to VCC. Let me check connections for the push button if they are correctly made. Yes, so now we can test our code. So first of all, we can of course check our code from here and confirm that the connections are right. LED connected to digital pin number 13, push button digital pin number 7. Our variable is value. So it's the one that we are using to hold or save or store the values that are read from the push button input. We're using LED as output, and then the push button is input. So I think we're okay with that. We're okay with that. So we can definitely start now our simulation. So if we start our simulation now, the connections I've made is the push button, the signal pin I've connected to terminal 2B, and then this terminal 2A I've connected through a pull-up resistor to ground. And then this other side, the terminal 1A, I've connected to VCC. So at the moment, the LED is off. Then we operate the push button by pressing it in. So if I press it in, we can see the LED is lighting. Press in, release, press in, release, press in, release. So as we can see, the LED is operating. Press in, release, press in, release, press in, release. And you can always change the color of the LED. Like if you wanted maybe say a green LED, you can change the color there. So you see it lighting. You see it lighting. And if maybe you wanted to use that same value to operate more than one LED, then you can just come, for example, and then connect another LED here and connect another LED here. So those are 3 LEDs. Let me give the first one color red. The first LED, let me give it color red. Then the second LED can be color yellow. Then the other one can be color green. Then you can put a resistor here. Then we can put another resistor here. So this anode can connect it here. Then again, connect it to VCC. Then this one I can come and connect this one to VCC. Then I connect the other legs to ground. So I can come, tap this one, connect to ground. Come, tap this one. Connect to ground. Let me just connect it up there. So those are 3 LEDs. Those are 3 LEDs. So if we want to run them through the same push button, then we can now make connections to that. So let me choose a different color. Let me choose green. So we can still tap this same control signal here, then connect it here. Then again, tap it. And connect it here. So those three LEDs there, they are sharing the same control signal. They're sharing the same control signal. So we can start the simulation. So if I press the push button, you can see now the LEDs are lighting simultaneously because they are sharing the same input device. You can see them lighting simultaneously. And there I'm still using the same code. So thank you very much for listening to me. In this example, we've looked at how we can read a digital input from a digital push button using Arduino microcontroller and using that value to turn on or off the LED. Thank you. That is all for now. Bye-bye. Watch out for our next video. In our next video, we will cover the analog input functions and an example on how to use analog input functions to read values from analog input sensors and use that value to operate digital output devices. Thank you. Bye-bye for now. In case you're watching this channel for the first time, kindly take a second and hit the subscribe button. For those who have already subscribed, thank you very much for your continued support. Bye-bye. See you next time.